So, welcome to part 3 of our information technology course for Ican. Uh, if you are looking for the part 1 and part 2, just go to my YouTube channel and you'll be able to get the part 1 and part 2. Part 3 is on software. Software. And here we'll be discussing about the various software applications that power the respective applications and your operating system and your computer system. Kindly like and share so that others will benefit what you are benefiting right now. This is a read along tutorial. So what it means is that I will read, explain, and at the same time, if you have your study pack, you can read along with me and jot your notes. Now, under this chapter, we'll be looking at the definition of software, system software, operating software, language processor, utility programs, processing environments, tooling, virtual memory capability, application software, file managers, and database management systems, presentation software, statistical packages, mathematical packages, integrated software, off-the-shelf, in-house package. Most of these topics I will treat, but not everything. I won't read everything particularly. I might just go through some and explain without reading them so that it won't take lots of our time. So let's go into the nitty-gritty of the write-up. Let's look at the introduction. Now, when we talk of software, from the introduction here, you can see that they said the software is a suite of programs that allow the hardware to function optimally and which allows the end user to interact with the hardware. The system software produced by the computer manufacturer, while the application packages are acquired from many sources. So let me just break this down for you. Every hardware component in life that man created needs a software application or a software package for it to function. There's hardly any hardware that is created. If you want to know the definition of an hardware, just read part 2 of this tutorial. So there's any hardware created without a software component being programmed into it. For instance, even our vehicle has its own software component. If you ask the electrical engineer for your vehicle, which we call a rewire, they tell you that the brain box is actually where the programming of your vehicle lies. So without the brain box, your vehicle is just a piece of metal, not functioning. Even if we want to go spiritual, we human beings, we can't live without the software. That's the breath of life. I don't want to go deep into that, but you understand what I mean. And as you know, your hardware is the physical component of the computer system. You can touch, you can feel it. The software aspect, you can't touch it, but you can see its operations running. From the text, I say the most important system software is the operating system. There are operating systems for various tasks or processes, such as single user, multi-processing, multi-programming, distributed processing, and multi-user. So let's go on. Now here, we have some definitions. It says software is a generic term for all computer programs that run on the hardware system and their accompanying documentation. The documentation, that is the complete set of instructions, enables computer system users to use the computer system to perform some tasks. Now you'll be wondering, what is all this grammar all about? Now a software is actually a programming package. created by a programmer using some set of programming languages to develop a particular application. That is all what software is all about. So software is that programming language developed by a programmer just to achieve a particular function. Now in software, we have what is called the system software or the operating system software. We also have what is called the application packages, or you are permitted to call it the application software. I will break those two down, but let's continue. The whole thing is about reading the text, so it's a read along. So I don't want to lose any of you while I do the explanation. But just jot down your points. It's very, very important for you to jot down your points. So the computer programs are divided into, as you can see, system software and application software, often called application packages. A computer program can be defined as a sequence of instructions to solve a particular problem written in a particular programming language. Now I've explained that earlier also. You can pause the video, rewind, and try to understand what I said just a few seconds ago. Now let's talk about the system software. They said this consists of background programs that enables application software, application packages to run smoothly on a specific set of hardware. In essence, system software refers to the suite of programs that facilitate the optimal use of the hardware system and provide suitable environment for the writing, editing, debugging, testing, and running of user programs. Thus, system software forms an interface between the application program and the hardware system. Usually, every computer system comes with a collection of these programs because they constitute an essential part. Most system software comes with the computer system and is often referred to as a bundled software. The type of system software includes operating system, language processors, utility routines, loaders, and editors. Now, as you can see, the system software comes with the hardware components. So if you go to the market, you buy a brand new laptop, a brand new computer system. It comes with a bundle package, which is the operating system that should be installed with it. Now, the operating system is the only software or the only application that sits directly or works directly with the hardware component of your computer system. But let me just break it down. The operating system is the one in charge of your central processing unit. So every other application, every other third-party software or any other application package installed must be installed on your operating system. You cannot install your application package before your operating system. That's why usually when you buy a flash drive and you insert it on your system, there's a prompt telling you that a new device has been detected, and subsequently it might ask you for the software, or if the system software operating system is pre-installed, it installs the driver before that device can work on your system. So now let's read more about the operating system. Most important system software, the most important system software is the operating system. It is the collection of programs that manage the computer-based information system resources in the wisest manner possible. It provides the user with features that make it easier to code, test, execute, debug, and maintain user program while efficiently managing the hardware. The function of the operating system include resource sharing. B. Provisions of virtual machine. Virtual storage is an interleaving technique performed by some operating systems in which disk storage is made to operate as a logical extension of the random access. Don't bother yourself about that, just understand. C. Memory management. D. File system. E. Protection and error handling. F. Program control. G. Initial setup of the computer when it is switched off on. This is achieved by the boot or bootstrap program, which is normally resident in the read-only memory. It leads to the rest of the operating system from the secondary storage into the random access memory. Main components of an operating system are: one, a supervisor; two, a command language translator; three, an input-output control system; and four, a librarian. Examples of operating system are your DOS, disk operating system, used on standalone microcomputers. Usually we call it MS-DOS if you are a core computer engineer. Then you have your Windows Office, which has your graphical user interface. You also have the Unix, UNIX. It's a multi-user, multitasking operating system used in micro and mini with Xenix and Venix as variants of Unix. You also have MVS, VM are used with IBM mainframe. You have the Novell NetWare, is a network operating system. You also have the Windows NT. And now, in our recent time, modern time now, we have your Android for your mobile phones and the iOS. Those are also operating systems that control the hardware components of your smartphone. But you download apps on them. Those apps have no direct impact in your mobile phone's central processing unit. It is the Android or the iOS that sits on the hardware of the processor before any other software can be downloaded on it. Now, Bootstrap program. This is part of the executive program of the operating system that resides in the memory of the computer system that is used to start up the system. The bootstrap, it is used as a startup, the booting process. When the computer is switched on, it must bring some of its controlling software into the main memory from the secondary or backing storage, and the operating system will take over the supervision of the computer's operation. In other words, Bootstrap is the program that calls in software that makes the computer operational. So it's just when you turn on your system, you see the system is booting or your phone is loading. So once you switch it on, it goes through a process of loading. That process is what it's doing is going through a circulatory method where it's checking the various hardware components of the system. If everything is still intact, then it will now call the operating system to function. The operating system will now load on your system and allows every other application to work perfectly. Language processor. A language processor, a language translator, is a program that converts the user's code, source code, or program into language code. The user code is called the source code, while the machine code is called the object code. So as you all know, our electronic devices, including our computers, don't understand our normal language. The language of your computer or all electronic device is a binary language. It doesn't. series of zeros and ones. So all your A, B, C, D or special characters you see on your keyboard are converted to machine languages zeros and ones. So as a programmer, if you are coding in any programming language like Java, C++, any kind of programming language, the you need a program translator, which in programming language we call it a compiler, to convert your source code, that's the code which you are coding. There's a compiler that converts that source code into an object code. The object code is the machine language. So as you can see from the diagram, you have your source code goes into the language translator, which is your compiler, then it's now converted to object code. It's that object code that your system understands. There are three most popular language processors, namely assembler, compiler, and interpreter. Assembler, these are programs which translate a source program into a low-level language, that's assembly language, into the machine code or object program. The translation process is performed by the computer itself. The process of the assembler is to simplify and speed up the tasks of the programming and enables the programmer to write programs in a language which in a language more simpler than the machine code. So I'll jump from there. Let's move on. So as you can see, I'm on figure 3.2 assembly conversion process. We have the low level language, which is the assembly language. We have the compiler for it called the assembler, which converts the code to object code. The compiler is what is we normally use freely. These are programs that convert a source program into a high level language. So the assembler is a low level language translator. The compiler is an high level language translator into machine code or object program. A compiler performs the task of assembling the object program, just like the assembly, but it is generally more complex. All the same, both compiler and assembly are performed to reduce the complexity and time involved in writing programs. The conversion of high-level language into machine code using compiler is represented in this figure 3.3. So compiler high-level language into machine and is converted to machine code. So we also have the interpreter. Interpreters like compilers convert high-level language into machine code or object code. But unlike compilers which convert into machine code all at once before programs are run, interpreter converts programs a line at a time as they are being run. With an interpreter, each statement is converted into machine language just before it is executed. No object code is ever produced. Basic programming languages uses the interpreter. So advantages and disadvantages of interpreters over compiler. I don't want to really waste much time on the advantages and disadvantages, but we can just pick one or two. So advantage and disadvantage of interpreter over compilers. Number one, they are fast and easy to use. Since one is not bothered with distinct and time-consuming compilation process. Number two, they produce superior error messages, which are easy to trace. Let's move on. And they are cheaper. Number three, the other ones, they are also cheap. So we have a table where you have the advantages and disadvantages. Advantages of interpreters over compilers. As you can see, number one advantage, they are fast and easy to use since one is not bothered with distinct and time-consuming compilation process. Disadvantage, it takes a longer time for a program to run. Number two, they produce superior error messages which are easy to trace. I've said that. The disadvantage, since it does not compile when a run program, is to be rerun, it needs to be interpreted all over again. So let's move on. So let's talk about utility programs. Utility programs. These are also called service or general purpose programs, as they are used for applications in general regardless of the nature of specific application program. They perform the following operations: file copy, file reorganization, file maintenance, sorting, dumping routines. This program transfer a working program of data into secondary storage. When you hear secondary storage, just have it at the back of your mind, your hard drive. So this program, that's dumping routines. This program transfer a working program data into secondary storage at regular intervals from where the program can be reloaded using a restart program. Housekeeping operation, that's number one, the operation is file copy A, B, file reorganization, C, file maintenance, D, sorting, E, dumping routine, F, housekeeping operations, G, conversion of program into ASCII or ASCII, ASCII code into EBCDIC code, and H, disk copying and formatting. Let's talk about the loader. So before an instruction can be executed, it must have been placed somewhere in the primary memory. That's usually your read-only memory or your random access memory. It is the loader that places the program segment into the appropriate location in the memory ready for execution. Thus, the output from the linkage editor during program compilation process is usually imputed to the data. Let's talk about the editor. The primary function of an editor is to convert inputs into a particular format output based on the editing command which accompanies the output. Most editors work on the source program, allowing the user to format, delete, insert, or modify all or parts of the file. We consider two types of editor: the text editor and the linkage editor. So what the editors normally do, most of the time, programmers use a form of text editor to code their program. You need a text editor first. That text editor now converts your program into the respective format which is meant to be converted to. That's all what it's saying. So this is text editor. The text editor is a utility program closely associated with application packages. We solve the problem of cutting and pasting programs together, changing data files by editing data files or changing the format of the data. Text editors are not word processors which are specially designed to prepare document material, e.g. letter and letter. But text editors lack the intensive text formatting and document printing capability. Linkage editor. This is a more important editor. It is a piece of system software. It works on object programs during program compilation, resolving undefined references, linking together several object programs which should work together, and reassuring all relocated reassuring all relocatable addresses. So let's talk about some phenomena or some terminology. This is like what you can see here, 3.4.1. Since we now examine some phenomena associated with system software. So multi-user application. When we talk of multi-user, it means it has more than one usage. Or when you say multi-user, it means more than one person can use it, multi-user. Now, as an application, it means that the application can be used in multiple different ways, or multiple people or multiple users can use that application. And the application which you know are usually the software application. So let's read. Multi-user or time-sharing application allows a number of users consisting of various people in different departments to process their own particular requirements in an online basis. It allocates to terminals. It allocates to terminal users several small fixed slices of time as their jobs are being processed. This way, the computer is able to work so quickly that each user feels as though he has exclusive use of the system. So multi-user application requires a terminal controller for controlling the operation of groups of terminals. When you hear what terminal, just have it at your mind, back of your mind, something related to a network or those cables connected to different systems, which allows everybody to have access to a network. And at the same time, we are all working together. So now it will now give you a feel as if you are the only one using that particular operation on the network at that point in time. So that is the definition of the terminal. B, if the terminal are located remotely, remotely means in different parts. So if the terminals are located remotely, it requires a modem, modulator or demodulator. You know what a modem is. Two, multiplexers, and three, front-end processor. C, private leased communication line. That's your network line. D, a powerful processor to support the multi-user environment as it must be capable of pulling the lines to allocate time slots to each terminal. Then large memory capacity for storing the various user programs, as well as a high overhead required for storing the operating system. F, protection features for preventing system crash as a result of several users processing the same file simultaneously. So then record your file locking and unlocking facilities to prevent a record file being updated by another user. So the individual terminal in a multi-user system cannot communicate with one another, this being unnecessary since they share common files. A major disadvantage is that if the connecting cable of the terminal is severed, it becomes inoperative as it has no link to the central computer, that's the server. Here, networking is distributed is an advantage because the microcomputer disconnected from the network can still continue the process. So multitasking environment. So this is a task. You can do several tasks at the same time in multiple times tasks. So multitasking, this refers to the ability, so we are talking of multitasking now. This refers to the ability of the microcomputer operating system to execute a user's task concurrently. For example, printing a word process document and typing simultaneously. Let's talk about multi-programming environment. This is a process whereby the mainframe computer works on several programs concurrently. Since a single computer can do only a single operation at one time, it will work on one program for a while, then switch over to another program. Thus, multi-programming, the operating system keeps the CPU busy. Time-sharing multi-user differ from multi-programming in that with time-sharing, a predetermined time slice is given to each user, while in multi-programming, the Time slice is determined by the input or output interrupts that are logically encountered in each program. Multi-processing environment. A multiprocessing environment or a parallel processing involves the use of several CPUs, that is processors, linked together to perform coordinated work at the same time. Note that in multi-programming, only one processor is involved. Spooling. Now in spooling, especially in a network, let me just explain this. What spooling does is that if multiple computers are making a request on a particular facility on the network, usually what the network does is that it arranges those requests according to the timing they came. So to now perform a spool, which means it will now start pulling each request according to the time that request appeared. So for instance, if in an organization you want to print and you have one computer, one printer in a network, and you have about like let's say 10 or 15 computers connected to the print server. What happens is that if multiple people are sending a print job simultaneously, as those print jobs are coming to the printer, they come with their own timing. So the server now arrange each print job according to the timing they came. So that is what is called spooling. So the printer will now start spooling, pulling or calling each of those print jobs based on the time they came for a request. So if you read this now, they say because of the low speed of the input output device, jobs are passed to the input device, which store the content in the magnetic disk that's arranged, which are later fed into the CPU. Because the speed of the magnetic disk is close to that of the processor, the result information are also transformed to magnetic disk, which later transfer them to a printer. This method of batching inputs and placing them in a magnetic medium and queuing the output on the same magnetic medium is a spooling. Virtual memory capability. In a virtual memory system, the operating system continually moves data back and forth between primary and secondary memory so that the system appears to have a virtually unlimited amount of primary memory. Application software. Application software is written to perform specific applications and to support users. Application software is divided into user application programs and application packages, which is used by specialists for generalized purpose. So let's talk about the user application program, in-house application packages. This focuses on expanding the role of the computer beyond traditional tasks. Examples include decision support system, expert system, and artificial intelligence. Application packages. These are pre-written computer programs that are widely used for specific applications in order to avoid unnecessary duplication of similar programs by many users. It consists of programs which carry out specific tasks for the user as opposed to the system software programs which control the working of the computer. A package consists of a suite of programs and documentation in the form of a program or system manual, which are detailed, which are details of how to set up the program and run it on a computer, and the relevant medium on which the program is stored, which is usually a magnetic disk or a CD-ROM. So what we are saying is that an application program is a pre-written program for a particular task. You have application packages, for instance, your Microsoft Office suite contains your Microsoft Word, your spreadsheet, your Excel, PowerPoint. All these applications are developed for specific use tasks. Your Microsoft Word is used for word editing, whereas your Excel sheet is a spreadsheet used mainly for calculation or accounting purpose. So all these applications are written, but they come with their own manual. And once you download or you store it in your computer system, it is being stored in your hard drive. That is what is called the magnetic disk. So once it's being stored in your hard drive, your operating system now calls for it anytime the user wants to use it. That's all what it's all about. As an example, we have some application packages on our microcomputers are your electronic spreadsheets. I've mentioned that word processing package, I've mentioned that one also. Then we have the file manager and database management system. We have applications for them also like your Oracle packages, your DBase package also, your Microsoft Access. These are all file managers or database management systems. So let's go on. The file manager is a proprietary application generator that allows users or programmers to organize data into files and processes those files one at a time. It is used for information retrieval and report preparation. File managers on microcomputers allow end users to create files with easy to use menu-driven routines that accompany the package. Although file managers can be used to create and store as many files as is necessary. It constrains users and programs from transparently interrelating data appearing in different files since it processes only a single file at a time. You also have other applications like your graphic generator, that's uh, your graphic generators, Corel Draw. You have your desktop publishing, Corel Draw, Adobe PageMaker also, the statistical package, mathematical packages. There are different application packages for different purposes. So if you want the one for graphics or statistical or mathematical packages, you get the application package for them. That's just maybe integrated software. This is a suite of programs that performs a variety of different processing operations using data which is compatible with whatever operation that is being carried out. Integrated software aimed at microcomputer system allows the user operations such as transferring data from spreadsheets into word processing documents. Example of such packages include your framework, enable, and your Symfony, JAS and MS Works. These are your integrated software. So these are software that enables you convert one particular application to another application or allows one application read another kind of application. So let's talk of off-the-shelf software. Off-the-shelf software, what it means simply is you pick something that is being bought off the shelf or it is being bought from a computer vendor. That is what off the shelf. You took it, the analogy is like you took it off your shelf. So these application packages which may be acquired separately or as part of an integrated system and are tailored to specific user requirements. Many application packages used by small organizations on microcomputers are off-the-shelf packages. Examples are your insurance software, banking software, security software, marine software. Advantages and disadvantages of off-the-shelf packages over in-house packages. We consider the merit and demerits of acquiring off-the-shelf packages over in-house applications developed from scratch. That's bespoke software. So off-the-shelf packages are already program packages which have already been developed. All you just need to do is to buy it from the software vendor and you are good to go. But when we talk about bespoke software are the customized kind of software which you specifically call a web developer or a programmer to come specifically to meet your specification. So it meets your specification and the software is customized for you and you alone. You don't find it in the open market. That is bespoke software for you. Off the shelf, you find it in the open market. You can call any vendor and buy it. Once it meets your requirement, you are good to go. But there are sometimes that there are some softwares that you don't want any other person. It's customized for you and you alone. That is bespoke software. So let's go on. So here we have advantage and disadvantage of the shelf packages and so you can read that one by yourself. So we have sources of application packages. Application packages can be acquired, rented or purchased from the following source. Mm, well, most of the things here are basically of the old school kind. A, mail order source as advertised in computer magazine. Over the counter from a retail shop or store, that's B. You can order it from a dealer, a vendor. D, manufacturers of microcomputer who also develop software. And E, specialist organization known as software houses who develop software. You have the checklist of selecting application packages. You can go through that. A computer bureau. Let's talk about computer bureau. A computer service bureau is a company that operates computer services to process data for other companies, particularly those which cannot justify acquiring a computer system. A computer bureau is a company, in fact, is a computer firm or an IT firm which provides computer services to other clients and customers. Types of computer bureau. We will consider two types of computer bureau. We have independent computers, independent companies. A, independent companies, independent companies specially formed to provide computing service to clients. B, computer users with spare capacity who allow other firms to use their computer system either for standby facility or for program testing to installation of a similar computer system. Service providers. Let's talk about service providers. A service provider by computer bureau providing a service provided by computer bureau. A, data preparation. B, program preparation and testing. C, hiring of computer time. D, hiring of computer system. E, do-it-yourself services. F, time sharing facility. We have sales of computer system resources. We have H, repair and maintenance. I, act as information center. A, system installation. K, training of staff. And you can go on and on. Reasons for using a computer bureau. Well, I will just pick 2 points. To obtain valuable initial experience of processing by computer system before deciding whether or not to install an in-house computer system. B, to provide standby facilities by arrangement in case of breakdown of an in-house computer. C, to provide facilities for coping with peak data processing load owing to insufficient capacity of the in-house computer. So you can read others. We have disadvantage of using a computer bureau. Now let's talk about introduction to computer programming. As you know, I've said computer programming is the ability for you to develop to code in any programming language to develop an application or a package. So what does the definition say here? The microcomputers have increased the computing capability of many non-computer professionals, and the use of application packages have become widespread. Some off-the-shelf packages, e.g. database package, can be made more efficiently and tailored towards specific processing tasks if the end user can write some computer code to supplement the package. We introduce this section the technique of writing packages and some important computer languages. So computer languages. The computer hardware processes data and program instructions which are in binary form called the machine code or language. The machine language is not very convenient for programmers because it is time consuming. Over the years, many computer languages have evolved and we now consider them. So we have the machine language, which I told you is a series of code of zeros and ones. It's a series of binary language. It converts regular language into machine readable object language, zeros and ones. Then we have the advantage, disadvantage. Let's go on. Then we have the symbolic assembly language. Assembly language is a second generation language developed around 1955 to 1965. It is a low-level language and the code are written in mnemonics, symbolic forms such as add, sum, mod. Assembly language must be translated into the machine language. Let's go on. We have the advantage, we have the disadvantage also. Then we have the high-level languages. These are third generation languages developed around 1965 to 1975. Examples are your basic language, your COBOL language, your Pascal language. A high-level language is written in the programmer's language, hence they are called natural languages. And there is less coding details to worry about. Anybody who knows a little about logic can write in high level. It is accessible to a large number of end users. A high-level language needs a language processor, such as a compiler or interpreter, to translate the code into machine object language. One high-level statement is translated into machine statement. This is one-to-many translation. I'll stop there. So I'll stop there. Let's continue. Now the features of high-level languages. One, facility to describe the nature of the data to be processed, especially for the data type. Two, facility to describe operators on appropriate data items, e.g. divisional operations on integer. Three, inclusion of allowable characters, uppercase and lowercase alphabet. You can read that one. That is the advantage and disadvantages also. So we have very high level languages. These are the fourth generation computer language. A fourth generation is an easy to learn, easy to use, more or less error-free, high productivity language. It can be created quickly and it involves much less maintenance. Very high-level language consists of a variety of software tools that enables end users to develop software applications with minimal or no technical assistance. Fourth generation languages are computer languages developed after the third generation language with the following objectives. It is intended to help users to develop their own application programs more quickly, cheaply, and easily. It demands fewer lines of code to achieve a given task compared to the third generation. It is non-procedural oriented language. That is, it only requires the user to specify the task needed and not how to do it. It is the best use of for retrievals. It is best used for retrievals and reporting of information. Examples are your report program generator (RPG), your structural query language (SQL), and the likes. In general, the fourth generation language can be divided into 7 categories: query language (SQL), report generation (RPG), graphic language, application generators, very high level programming languages. So let's go on. We have the fifth generation language, which is called the Object Oriented Programming Language, OOP or OOL, an approach to prevent the complete rewriting of new program line by line is to introduce a form of a subroutine called object. An object is a predetermined set of program code that, after having been written and tested, will always behave the same way so that it can be used for other applications. In object-oriented programming, an object is written for each specific task and saved in a library so that anyone can use it, rather than writing a new program line by line. A program selects objects by pointing to a representative icon and then linking these objects together. Objects can be modified, used, copied, or created. Advantages of object-oriented programming. It uses graphical user interface. 2, it is easy to use. 3, faster program development. 4, enhances programmers productivity. 5, program produced are more reliable and contain fewer errors since the module being used have already been extensively tested. Disadvantages: it has a steep initial development cost, more extensive startup time, and 3, program produced which are larger, slower, and use more memory and other computer resources than program produced by traditional methods. Example of your object-oriented programming are your C++, Java, Visual Basic. So let's talk about programming procedures. Problem definition. The first step, so programming procedures are the routines, the procedures which you will take before embarking in coding. So you have to define the problem definition. Know what the task is all about. What do you want to achieve? Program definition. Number 2, you're developing algorithm. The algorithm are the lines, stage by stage coding lines which you are going to write. This is a step-by-step logic that should be followed in writing a particular program. So the algorithm are those line by line codes that you've written in your text editor. So it's called an algorithm. And number 3, program design. This helps to give clear logic of the program pictorially. Various programming tools of design are flowcharts, pseudocodes, decision tables, and decision trees. Number 4, program analysis and modeling. This enables the programmer to determine the complexity of the program. Factors to be considered for selecting a particular programming language. The various factors to be considered in selecting or adopting a particular programming language include: 1, the development cost. 2, availability of language translator. 3, proficiency of the object programmer. 4, degree of portability or compatibility of the program. 5, machine cost on cost effectiveness. 6, time to be taken in writing the program. 7, readability of the language. 8, machine, that's efficiency of the language for each acceptance by context. Quality of a good program. We talk of the reliability one, portability two, readability three, performance four, stage space five. So that is that about that. Introduction to grind computing, grid computing. Grid computing and data resources to perform that task. Client has no knowledge about where the work is executed. The task is returned to a client once it is completed. The resource fee is handled by a grid manager. On the other hand, the functioning of cloud computing is such that work is submitted by client to the cloud server. The cloud server can be established internally or as parallel servers or distributed servers. The service fee is handled by utility computing. Application-wise, the grid computing is mostly used in remote educational services, bioinformatics, data storage, and chemical calculation processing. You can read the merits and demerits of grid computing application. You can go through that one. The limitation of grid computing, you can go through that also. Types of grid computing, you can read it. This might come out in your respective short answer questions. Application areas of grid computing, documentation tools. We now develop the technique for writing and properties of a program. The algorithm, as I earlier mentioned, the algorithm is a finite sequence of instructions to solve a given problem. For example, to find the product of 10 non-zero numbers, we obey the following instructions. Input the first two numbers, find the product and call this product prod. Input the third number and find its product with prod also. D, continue this way until we reach the 10th number, multiply this also with prod, and E, prod is now the product of all the 10 numbers. Properties of an algorithm. An algorithm also has the following property. It begins with an instruction to accept data. 2, the processing rules specified in the algorithm must be precise and unambiguous. 3, each instruction must be sufficiently basic. 4, the total time to carry out all the steps in the algorithm must be finite. And 5, an algorithm must produce one or more outputs. Programming. A computer program is an algorithm written in a particular computer language, either in machine language, symbolic assembly language, any of the high-level language, or very high-level language. Computer operations. The basic operations performed in a computer are arithmetic operations, input and output operations, and finally the logical operations. You can read those ones clearly also. So now let's talk about branching operations. Computer program instructions have three logical structures, namely sequencing, selection, and repetition. Sequencing. Computer instructions are obeyed as they are written in a sequence. For example, read a data item from a file. Write this data item into another file. Selection instruction. Number 2, selection instruction. This offers the program some choices and the sequence action taken depend on the choice selected. Example of selection instructions are logical if, arithmetic if then else, go-to case, repetition or looping. Sometimes a program is required to execute certain basic instructions several times. The repetition of a sequence of same program instruction is called a loop. So, can read the principle of a good programming, aims of a programming technique. These are just things you can just glance through. The software engineer, who is the software engineer? Software engineer is the adoption of a systematic method and engineering principle to the specification, design, implementation, and testing of programs, including the management of such activities. Literally, software engineering is just another name for good programming principles and practice. It is nevertheless a useful term to use when one wishes to indicate that what is meant is professional software development, industrial standard rather than amateur code writing. So what software engineering means, what it simply means is a software developer. But if you want to be professional, you tell people that I'm a software engineer. A software engineer is a programmer, a software developer that develops application packages. So I will stop there. Then watch out for my subsequent editions also. Kindly like and subscribe to this channel. And as I said earlier, this is a read along. So the whole essence is for you to take your study part and read along with me. Then use this video to break down some of the things that might be confusing to you. So till we see next time, please bye bye for now.